Now today we will discuss the drilling machine, which is very important for exam point of view. Now drilling machine, a power operated machine tools which holds the drill in its spindle, rotating at a high speeds, and when actuated move linearly against the workpiece, produce a hole. What is drilling? Drilling is the process of cutting holes in metals by using a drilling machine and a drills. The drilling operation can also be accomplished in lathe, in which the drill is held in tailstock and the work is held by the chuck. The most common drill is used is the twist drill. Now in this belt drive system, we'll see the significance of the drill machines. The types of drilling machines. Depending on the design, construction and uses. The portable drilling machine, sensitive drilling machine, radial drilling machine and upright drilling machine. The portable drilling machine show this diagram of the portable drilling machine, which is used for the domestic purpose also. The sensitive drilling machine. Drill holes from 1.5 to 15 millimeter. Operator senses the cutting action, so sensitive drilling machines. Sensitive drilling machine show the systematic diagram of the sensitive drilling machine. Bench drilling machine. These are light duty machines used in the small workshops, also called the sensitive drilling machines because of its accurate and well balanced spindle. Holes of diameter is 1 millimeter to 15 millimeter. Upright drilling machine show the systematic diagram of upright drilling machine. Drill holes up to 50 mm. The table can move vertically and radially. Box column and round columns type. Radial drilling machine show the schematic diagram of the radial drilling machine. In the largest and the most versatile used the froe drilling medium to the large and heavy work pieces. Now in this radial drilling machine, these are heavy duty or versatile drilling machine used to perform the drilling on a large or heavy workpiece, hole up to 7.5 centimeters. Hand drills. Now pistol grip drilling machine, a drill in the shape of pistol, commonly called electric hand drill. Cordless drills. A cordless drill is the type of electric drill which uses the rechargeable batteries. Parts. The vertical main column, base column, moving drill head, work table, electric motors and variable speed gearbox and spindle feed mechanism. Show with the help of these figures what is the basic use for this kind of drilling machine. The parts. Column supports the radial arms, drill head and motor. The raise or lower the arm by elevating screw mechanism. The radial arm, the raise or lower, accommodate the workpiece of different height, may be swiving around the column. The drill head carries drill, spindle and drill bit. The mechanism for rotating and feeding the drill can be moved horizontally and to position. Work table made of cast iron. The based on movement of radial arm and tool head. The plain radial drilling machine, vertical adjustment of arm, horizontal drill head movement along the arm, the circular movement of arm about the vertical column. The semi-universal drilling machine. The fourth moment, the drill can be swing about horizontal axis perpendicular to arm. The universal drilling machine. The fifth moment, radial arm rotates the horizontal axis. Work holding. Now we will discuss the work holding. Work holding device. The T-bolt and clamps, step blocks, V-bolts, angle plates, drill jigs, and drill press wise. Now the direct clamping. How the direct clamping will be performed in the industrial purpose. Step blocks. In conjunction with the T-bolts and clamps, the support to other end of clamp, the step for leveling according to the height of work, the made of mild steel, V blocks and clamps used when the drilling round bar. Now we will discuss the angle plate. The basic use of angle plate. The made from high quality material stabilized to prevent further movement distortion. The slotted holes or T-bolt slot to enable clamping of workpiece to the plate and the plate to the work plate. Drill jigs. Drill jigs is used for the mass production and hold the work securely, locate the work and guide the tool. Can be clamped and unclamped quickly. Special design according to the work. Drilling machine. The machine vise has slots in the sides of the base of the vise which enable the user to screw the machine vise to the drilling machine table. Drill material. The two most common types, high speed steel drill, low cost, carbide tip drill, high production, and in CNC. Drill bit. The drill bit is a multi point tool and typically has a pointed end. A twist drill is the most common type used. Drill bit. Flutes are incorporated to carry away the chips of metal. Shank provided the drive. Can be tapered or parallel. Body tapered slightly in diameter from tip to the shank to provide the clearance. Drill bit. Straight shank and taper shank. So with the help of this figure, the what is the basic difference in between the straight shank or taper shank. Twist drill. The twist drill are available with the parallel shanks up to the 16 millimeter diameter and with the taper shanks up to 100 millimeter diameter and are made from high speed steel. The different helix angle are available for the drilling a range of material. Tool holding device. Now, next is the tool holding device. The tool holding device, the different methods used for holding drill in a drill spindle are by directly fitting in the spindle holes, by using the drill sleeves, by using the drill chucks, or by socket. Drill fixed to the spindle. Tool holding. Drill chucks, the most common device used for holding the straight shank cutting tools. Most contain the three jaws that move simultaneously when outer sleeve turn. The whole straight shank of cutting tool securely. The two common types, key and keyless. Key types, the most common tighten with the key and different size keys for the different size keys. Keyless, the chuck loosened or tightened by hand without keys. The precision keyless hold smaller drill accurately. The drill chucks. Sleeves, where a cutting tool or chucks has a Morse taper smaller than that of the spindle, the difference in the made by using a sleeve. Morse taper sleeve. Morse taper sleeve. For example, a drill with the number of Morse taper shank to be fitted in a spindle with the number of two Morse taper would require one or two sleeves. Drill socket used often as extension socket. Drill drift. Now, what is drill drift? We will discuss the drill drift. To remove the shank from the spindle, a taper key known as a drill drift is used. Using the drill drift, the drill is inserted through a slot in the spindle. Twist drill manipulation. We'll discuss the twist drill manipulation with the help of the slides. The manipulation of the twist drill is shown in a figure. The drill twist element, the following are the twist drill element. Axis, the longitudinal center lines of the drill, and the body, that portion of the drill extending from the extreme point to the commencement of the neck, if present, otherwise extending to the commencement of the shank. The body clearance, that portion of the body surface which is reduced in diameter to provide the diameter clearance. The chisel edge, the edge formed by the intersection of the flank. The chisel edge is also sometimes called the dead center. The dead center or the chisel edge act as a flat drill and cut its own hole in the workpiece. A great amount of axial thrust is required to cut a hole by the chisel edge. In some drill, the chisel edge is made the spiral instead of the straight one. This reduces the axial thrust and improve the hole location. Chances of production of oversized hole is also reduced. The chisel edge corner, the corner formed by the intersection of a lip and the chisel edge. Face, the portion of the fluid surface adjustment to the lip on which the chip impinges as it is cut from the work. The flank, that surface on the drill points which extended behind the lip of the falling flute. Now, what is flutes? The groove in the body of the drill which provide lip. The function of the flutes are to form the cutting edge on the point, to allow the chips to escape, to cause the chip of gruel, to permit the cutting flutes to reach the cutting edges. Now, next is the heel. The edges, the edge formed by the intersection of flute surface and the body clearance. Lens, the cylindrically ground surface on the leading edges of the drill flutes. The width of the lens is measured at a right angle to the flute helix. The drill is full size only across the lens at the point ends. Lens keep the drill aligned. Now, what is lip? The edge formed by the intersection of the flank and face. The requirement of the drill lip are both lips should be at same angle of inclination with the drill axis 59° for the general work. Both lips should be equal length. Both lips should be provided with the correct clearance. Neck, the diametrically undercut portion between the body and the shank of the drill diameter and other particulars of the drill are Outer corner. The corner formed by the intersection of flank and face. The point. The sharpened end of the drill consisting of all parts of the drill which is shaped to produce the lips, face, flanks and chisel edge. The right hand cutting drill, the drill which cuts when rotating in counterclockwise direction viewed on the point end of the drill. The shanks, the parts of the drill by which it is held by and driven. The most common type of shank are taper shank and the straight shank. The taper shank provides means of centering and holding the drill by friction in the tapered end of the spindle. Tanks. The flattened end of the taper shank intended to fit into the drill slot in the spindle socket or drill holders. The tang ensures the positive device of the drill from the drill spindle. Web. The central portion of the drill situated between the roots of the flutes and extending from the points towards the shank, the point end of the web or core from the chisel edge. Now, drill twist and helix types. The helix angle of the twist drill is the equivalent of the rack angle on the outer cutting tools and is established during the manufacture. The standard helix angle is 30 degrees, which together with the point of the angle of 118 degrees is suitable for the drilling steel or cast iron. Helix types. Helix types, the drills with the helix angles of 20 degrees, known as the slow helix. The drills are available with the point angle of 118 degrees for cutting brass or bronze and with the point angle of 90 degree for cutting plastic materials. The quick helix drills with the helix angle of 40 degrees and a point angle of 100 degrees are suitable for drilling the softer material such as aluminium alloy and copper. Now, drilling process. Drilling operation. Operation that can be performed in a drilling machine are the drilling, reaming, boring, counter boring, counter shaking, taping. Operation of drilling machine. Drilling operation in drilling machine. Counter bore and spot facing. Typical drilling process. Show with the help of this figure the typical drilling process. And now come to the reaming. What is reaming process? The reamer enters the workpiece axially and enlarges an existing holes to the diameter of the tools. The reamer is a multi-point tool that has many flutes, which may be straight or in a helix. The reaming removes a minimal amount of material and is often performed after the drilling to obtain the both more accurate diameter and a smoother internal finish. Reaming process. Counter shaking. Counter shaking. Counter shaking tools enlarges the top portion of the existing hole to a cone shaped opening. The counter shaking is performed after the drilling to provide the space for the head of the fastener, such as a screw, to sit flush with the workpiece surface. Cutting speed, half of the cutting speed of the drilling for the same holes. Counter shaking. Common included angle for the counter shaking include counter boring. Counterbore tools enlarges the top portion of an existing holes to the diameter of the tool. The counter boring is often performed after the drilling to provide the space for a head of a fastener, such as a bolt, to sit the flush with the workpiece surface. The counter boring tool has a pilot on the end of to guide it straight into the existing holes. Counter boring. In this counter boring, the cutting speed, the two threads of the drilling speed for the same holes. Counter boring fit. Spot facing. The spot facing provides a seal of flat surface to entrance and surrounding area of holes. This flat surface allow the bottom of the screw or bolt to sit securely with the material. The spot facing is commonly done on casting where irregular surfaces are found. The spot facing may be performed on the drill press with a counter bore of suitable size for the operation. A proper size pilot must be used whenever there is done on the drilling press. The spot facing. It is finishing operation to produce the flat round surface, usually around a drill hole, for proper setting of bolt head or nut. It is done using special spot facing tool. Spot facing. Spot facing, where the holes in two parts are required to line up with each other, a technique known as spotting is carried out. The top part is marked out and drilled. The two parts are then carefully positioned and clamped together. Spotting. The holes in the bottom parts are transferred by spotting through from the top parts. The drilling the drilling of the bottom parts that can processed in the knowledge of that both sets of holes are identical, which may not be the case if both the parts are marked out and drilled individually. Boring. It is the process carried on a drilling machine to increase the size of an already drilling holes. Initially, the hole is drilled to the nearest size, and using a boring tools, the size of the hole is increased. So, with the help of this figure, the operation of boring, the taping, the process of cutting internal threads with the threads tool are called tape. Pilot drilling. Pilot holes is a smaller hole drilled before a large one. Angle plates and step blocks. Drilling hole to depth. The hole can be drilled to a particular depth by setting the depth spot stop on the machine. Drilling thin material. Cutting speed. What is cutting speed? The cutting speed for the drilling is the rate at which the tool passes over the surface of the metal. That is how the fast the cutting tool is in spinning. It is commonly expressed in meter per minute. Cutting speed depends on the material being cut and the condition and the strength of the tool and machine, depth of cut, rate of feed, and material on which the tool is made, availability of the cutting fluid, and the size of bit being used. The cutting speed selection. The softer the work material, the faster the recommended cutting speed. Show with the help of this figure how the increasing cutting speed. The hardness of the cutting tool material has a great deal to do with the recommended cutting speeds. The harder the cutting tool's material, the faster the cutting speed. The softer the cutting tool material, the slower the recommended cutting tools. Calculating the cutting speeds. With the help of this figure, we can easily calculate the cutting speeds, spindle speeds. Now, next is the spindle speeds. The rate at which the spindle rotates, it is commonly expressed in revolution per minute. Now, with the help of this formula, mathematically we can calculate the spindle speed in revolution per minute. Here, the cutting speed in meter per minute, and where the pi is 22/7 or 1.3.142, and d is the diameter of the material, and n is the spindle speed revolution per minute. Now, with the help of this example, we can easily understand all these things. Calculate the revolution per minute required to drill a hole's 15 millimeter diameter in a piece of machine tools. Find the cutting speeds of 10 diameter drills with a spindle of 178 revolution per minute. Similarly, we can use this kind of example to understand all these things. Find the cutting speeds for the diameter 9 spindle speed 180 revolution per minute, diameter 6 spindle speed 20 revolution per minute, diameter 5 spindle speed 160 revolution per minute, spindle speed 120 revolution per minute, diameter 10 Similarly, we can discuss the next problem which we are describes in below. Thank you.